Hello, 8th graders. In lesson 4 here in unit 6, we're going to be fitting a line to data and looking at the trends on the scatter plot. In the first problem here, you're going to use the scatter plot to make a prediction. Read the problem, answer the question, and be sure to explain your reasoning. As I'm looking at the trend in the data here, if the car weighs 1,750 kilograms, it looks like its fuel efficiency is going to be much closer to that 22 miles per gallon range rather than being up here at 28 miles per gallon. As we start this next problem, it is looking at the weight of diamonds. Weight of diamonds is measured in carats and giving the price for those different weights. Now, as we can imagine, the bigger the diamond, the more it's going to cost, and that's generally what we see happening here. You'll see a line on this scatter plot, which is different from what we've usually seen. That line is the line of the equation right here, and that equation is the model of the relationship between the diamond's weight and its price, and we can use that model to make some predictions. So that's the main thing we're looking at today. We'll start with this first problem together. We have the table of data, we have the scatter plot of the data, and then the equation for the line or the model. And if two diamonds both weigh 1.5 carats, what are their prices? We can see that in the table right here. There's two diamonds right there, both 1.5 carats. You can see one price is in the 7,000 range and the other price is in the 5,000 range. So in the table, we can see the exact prices. On the graphs, we can see these two diamonds right here, and we would have to estimate their prices from the graph. In number 2, now we're going to use the model to look at the price of a diamond that is 1.5 carats in weight. The model says that the price is going to be $7,189. We can see it on the graph right here. We're looking at where the line is for a diamond that's 1.5 carats in weight. And how can we use that with the equation? Well, I'm just going to take my equation, and instead of x, I'm plugging in 1.5 because that's representing the weight of the diamond. And when you use your calculator to evaluate all of this, you would get $7,189. So that's how the equation can tell you the exact price or the exact predicted price for a diamond. In number 3, we're looking at a diamond that has a weight of 1.9 carats. What does the model predict for that price? Again, plug in 1.9 for x, evaluate that, and the model predicts it would be $9,397. How does that compare to the actual price? I'm looking over here in the table. For 1.9 carats in weight, the actual price was a little bit more than the predicted price, but it's still pretty close. Right here at about 1.2 carats is a diamond that falls pretty much right on that predicted line for the model. And in the table, I can see that right here as well. And the actual price is just $11 off from the predicted price. So for that diamond, the model predicted its price very well. Right here is an example of one diamond that is not predicted as well by the model, and that's just because it's further away from the line. If I look at, going straight up, it's just further away than the other diamonds are. And on the table, I can see that right here. And its actual price is pretty far away from its predicted price. In activity 3, you're using the scatter plot to look at some data about feet. Go ahead and answer questions 1, 2, and 3 and start again when you're ready. Here are some estimates from the graph. We are estimating because we don't have a table to give us exact values here. Longest foot would be this one right here at 30.2 centimeters. Shortest would be over here at 21.9 centimeters. The narrowest foot is way down here at 7.4 centimeters. And the widest is this one up here with 11.8 centimeters. The one point on this graph that seems weird is this one down here. And when you have a point that's so far away from all the other data, we call that an outlier. So be sure you label that. In lesson 5, we're looking at trends in a scatter plot and also looking at associations. We could give a reason for each one of these scatter plots as to why they don't belong. This one is the only one that has a model that shows a positive slope. This is the only one that has a model line that shows a negative slope. This is the only one that has no model line drawn. And this one is the only one with data that goes into the negatives on your y-axis. For this activity, I do want you to use a pasta and a straight edge or a ruler. That's just going to help you make sure that you're drawing straight lines for this. Our goal here is to draw a line that is best showing the trend of the data. I'm going to use this blue line right here, and if I'm going to show the trend of this data as best I can, it's going to be about like that. Notice that I have about the same number of points above the line and below the line. Oops, sorry about that. Above the line and below the line, and I'm trying to show that general pattern, that negative slope in this case. So go ahead and try the next few problems and then start again when you're ready. Looking at these two scatter plots, my line of best fit should look something like that. One common mistake that people make, I'm going to do it over here on the right, is that they will draw a line, look something like that, and they'll say, yep, I split my data in half. I have the same number of dots on both sides. Well, yeah, that's true, but you're not showing the trend of the data. And remember, our goal is to show the trend of the data. So on here, if I'm going to show the trend of the data, it should probably look something like that. That's probably even a better line than that first one I had drawn. Okay, so go to your lesson synthesis and find this graph in there. We're going to take a couple notes. Just to wrap this up, this entire graph is called a scatter plot. But this line that we drew, we've used a couple different words for it. We've called it the model, and that's usually when we have the equation for it and we're using the equation for something. We've also called it the trend line because it shows the best trend of the data, and we've also called it the line of best fit. So you may hear any of those terms being used for that line.